Record. Okay. All right. Well, welcome back, everyone. Seems like the school is kind of finalizing all their designs for second trimester. We still don't know yet if we're going to get into the hybrid setup or if it's going to be back full time. I'm kind of hoping for the school it goes back full time because those poor ladies in the office are trying to figure out where to put everyone, and it is a nightmare. So hopefully we just go back to school and everything will be nice and easy. So as you can see, I'm over at home again today. I was just leaving this morning at like 6:30 and going into school, and I see the construction crews out in front of my house, and I guess nobody told us, but we have to get a new sewer, what do they call it, a clean out, installed in our house. And so it's this giant job where they have to rip out all the concrete at the house in our driveway, and I'm like, oh God. So that was my surprise this morning. So that's why I'm at home, because I want to make sure everything gets done right and they don't leave some kind of hack job there. So anyways, that's why I'm home. Wasn't good news, but that's nevertheless why I'm here. A couple of things. So I do have the weekly announcements I need to show you today. I couldn't find them yesterday, so I'll show you those today. And then on top of that, we'll continue on with our notes for the class and keep moving along with electrical notes. I think I told you yesterday I was going to give you 2 days to catch up, but I forgot you guys actually have a little less on the process journal than the other class. So I'm just going to move ahead with the electrical notes today, okay? And we're getting to good parts of it soon. And I was looking at the notes today, I saw we're getting close to the electrical wiring diagrams, which I think are one of my favorite parts of electricity. It's like a whole new foreign language for electricity. So it's really fun, I think. All right, let's see here. Bonjour, huh? A lot of French people in here. All right, let's see here. Let me find my notes. Oh, actually, let me do the student announcements first. Okay, so I'll share the screen. Okay, and then let me just pull up chat and then I'll be ready. Okay, very good. All right, here we go. So, oops, I jumped up Tuesday. I wanted this one. Uh-oh, what happened to Monday? Shoot, she just changed this on me. I had this open today and it had the video ready to go. So sorry about that. Where did the video go? And I think they just changed it on me because there's no Monday anymore. What the heck did they do with Monday? Well, I don't know. Oh well. I guess we'll have to do that some other time. That's all right. I think they accidentally erased Monday because it goes from Friday to Tuesday. Okay, I'll get rid of that for today then. And we'll go to basic electricity. Okay, so that's some Ohm's law stuff. We'll be doing that a little bit later. Okay, we're gonna skip through a bunch of this stuff here because this is what we already did. I was looking, we actually got pretty far so far. I did wanna review this part real quick. So remember, we're gonna use conductors and insulators quite a lot in this class. So conductors are gonna be metal for this class. There are a few others, but in general, metal is our good conductors. And we're gonna use almost exclusively copper in this class. Okay, copper is probably one of the best combinations of price, weight, thermal expansion, and electricity conductivity. So it's like the happy medium. So copper is what is used most of the time. However, there are times when copper becomes real rare and we'll switch over to aluminum. So aluminum is used sometimes when you need really big, fat, thick wires because it's cheaper. So it doesn't hold as much electricity. So if you're going to use, like, let's say you want to run 100 amps through something, you'll need a bigger cable of aluminum than you will of copper. So there are disadvantages to aluminum, but one of the nice things is it's a lot cheaper. So sometimes we end up switching to aluminum. In this class in general, will just be copper. Okay, so that's conductors, and those are going to be wires. Insulators are going to be anything that stops electrical flow, and that's going to be your rubbers, woods, ceramics, and plastics. We will use these to keep people safe from electricity, okay? It keeps the electricity where it's supposed to go. We are very close to Ohm's law. We use Ohm's law throughout the class, so we'll be using it all year long. Okay, next up. Semiconductors. We won't talk about these for a little while, but just remember the one we're going to see a lot of is silicon. And silicon is one of the materials that is a semiconductor. And just remember, semiconductors can be either conductors or insulators. And that's the magic of them, because we can use electricity to switch these things back and forth millions of times a second. So it's that was a huge invention when we got those. Okay. Then what we're talking about today are the three terms that we need to know when we talk about electricity. This is probably the most important part of electricity, is to know these three terms. If you don't know these three terms, the whole rest of the year is worthless. Well, not totally, but everything in electricity counts on these simple terms here. Let me see here. Yes, Suleiman, we will do transistors when we do the robots. And let's see, yep. Okay, so voltage, current, and resistance. Okay, those are the three things that you have to make sure you know. So if you're paying attention to anything intently, this is the things to pay intently over. Okay, these are the most important things. Okay, so let's talk about voltage first. Okay, voltage. So the first variable that we're going to mention is voltage, and voltage is electrical pressure. Okay, we don't normally think of electrical pressure, but if you think of water, it's very similar. So when you turn on your hose and you just let your hose flow, your hose has a high volume of water, but it doesn't have a very high pressure. It only has like 50 psi or so. Okay, so not that much, 50 pounds per square inch. So everyone just picture in your head for a second turning on your hose. Okay, and you can picture the flow coming out of the hose. You know, it'll maybe go about 3 or 4 feet and then it'll drop to the ground. And then if you put your hand over the hose, you're instilling some resistance to it, and you're going to make the pressure go up. And then as soon as you put your finger over the hose and you make the pressure go up, you know how the water will shoot like 5 times as far. You know, it'll probably shoot 20 feet, 30 feet, and you can make it squirt. So that's what pressure is. The more the pressure is, the harder it's going to push out that water. Okay, so we need voltage in electricity because pressure is what makes that electricity move. Okay, and when you need electricity to move a long distance, then you need lots and lots of pressure. Okay, so when we talk about our household voltage, anyone know how many volts that is? Yeah, Reed.
120.
Yeah, 120 volts. Good. Okay, and we do have 2 circuits in our house, so we can get up to 240 volts. But the pressure on the lines, the electrical lines outside, that's 12,000 or 13,000 volts. Okay, and that's when they need that much voltage to push the electricity. Okay. So voltage is the same thing as electrical pressure. The technical science term is electromotive force, EMF, okay, electromotive force. But on your notes, I want you next to voltage to have pressure, okay? This is electrical pressure. That's the most important thing. That's the pushing power of electricity. Hold on, I'm getting some questions here. Something about... Okay, so then we're getting frequency. Frequency is how quickly the electricity moves in a wave pattern. So the frequency is how quick it goes from a peak of the electricity to the next peak. So if it has a real slow wave like that, then it's going to have a low frequency. If it has a really fast wave, then it's going to have a high frequency. Frequency is going to be 60 hertz in the United States. So we'll talk about that in a little bit. That's a little more complicated thing. When we get into alternating current and direct current, we'll talk about that. So that's frequency. Frequency is 60 hertz, 60 times a second. Okay, let's see here. All right, so we've got voltage is electrical pressure or the pushing power of electricity. It's important to note that the higher the voltage, the farther you can push the electricity. And same thing, remember we said like at 50,000 volts, you can get electricity to jump through the air. So that's the thing, as you increase the pressure, you can get the electricity to do more and more things like that. Okay, but that's the electrical pressure, that's the pushing power of electricity. So high voltage is not what kills you. People can survive lightning bolts, they can survive being shocked by very high voltages. Okay, so voltage is the pushing power, and that's why voltage doesn't kill you. The voltage will hit you hard, but it's not a lot of electricity. Okay, and we'll get into the next thing, and you'll see the difference. Okay, so just remember, this is This is pressure or pushing power of electricity. It's called voltage or electromotive force. Let's see. Do I want you to write any of this? Do not write any of this, but I'm just going to talk about it. When we do Ohm's law, it'll make more sense. So the higher the voltage, the more current flow it can create. Okay, so obviously the faster you push something or the harder you push something, the more flow you can generate. Okay. That makes sense, I think, just intuitively. And then the other thing is to keep the current flowing, it's necessary to maintain electrical pressure. And the main reason I want you to know this is as a battery gets drained, the voltage is going to drop, 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 drop. And eventually there won't be enough pressure and it won't be able to push any more electrons out of the battery. So I just wanted you to know without any electrical pressure, no electricity will move. Okay, so that's important to know. Okay, and the next thing I want to do is check the time real quick. Okay, so we have to end at 9:37. Okay. All right, as we have these quick classes, I want to make sure I don't run over. Okay, the second one up is going to be amperage or current. Okay, so put current down in your notes. Oh, hey, go back to voltage for a second. I forgot, I wanted you to write something. So for voltage, I want you to put V, just put like in parentheses the letter V. Okay, that's the shorthand for voltage. So we'll be using that all the time when we do math. Okay, so that'll be voltage is V. Okay, and then over to current now. So electrical current, next to current, I want you to put amperage and then apostrophes and an A, and then apostrophes and an I, okay? Okay, so electrical current is the amount of electrons moving through a wire. So this is when we talk about current, we're talking about the amount of electricity. Current is what is deadly, okay? Current is the thing that kills people. Current is the amount of electricity going through you. So the more electricity going through you, the more work can be done. And when it's going through your body, that means heating you up and killing you or stopping your heart. So current is the thing that's very dangerous. So if you're shocked with a very high voltage, but a very low current, you're typically going to survive. If you're shocked with a low voltage, but a really high current, your chances are not very good. Okay, so as we start to get into these three, you got to understand the differences between them. So voltage is the pressure, that's the pushing force. Current is the amount of electricity, okay, the amount of electrons actually going through you or through the wire. Okay, so now there's some abbreviations for current. So one of them is called AMP, which is short for amperage, which is a measurement of how much electrons are flowing. And then there's also, when we do the math of it, sometimes you'll see an A for amperage, but more typically you're going to see an I, a capital I for intensity. Okay, so put down a little parentheses brackets and put an I, do a parentheses brackets and an A, parentheses brackets and an amp. That way we know all the abbreviations. So when you come back and see it, you'll have it in your notes, okay? So it could be a capital I, a capital A, or it could say amp too. We use all three of those. Okay, what else do we need to know? Yeah, so it just says it may be compared to water too. Again, this is the amount of water flowing. So if we use a water example, your hose is very, very high amperage. Okay, your hose is high amperage, but it has very little pressure. Okay, so it's going to put a lot of water out, but it's not going to push it very far. Now, if you change to a pressure washer, you've seen those things that the engines are like, and they're spraying water, and it's just like taking paint off of fence boards and all that stuff. So that's the opposite. Those are high pressure, low amperage. Okay, your hose is high amperage, low pressure. So there's a relationship between those that we'll talk about later. But that's, you can think of electricity in those terms because it's kind of hard to see electricity. Okay, so which one of these is deadly again?
The current.
I couldn't hear you.
The current.
I think my computer's super quiet. Amps anyways, okay? Amps are gonna be the ones that are deadly.
Yeah, amps.
Okay, good. I thought that's what you were saying. It was quiet. I have the headphones on partially, so I think it blocks some of the sound. Okay, and then the third one that we need to know, wait, what happened to, there we go. Yeah, I wanna go back to that one. And the third one is gonna be resistance, okay? I usually have a whiteboard in front of me when I'm doing this. So the third one that you need to know is resistance. And I'm gonna go pick up, let me just go show this resistance. There we go. That's a good one right there. Okay, so you see this little horseshoe shaped thing here? That's gonna be the symbol for ohms or resistance, okay? That's the symbol we're gonna talk about. Sorry guys, I cannot hear at all today. That just sounded like a robot talking. So I'm not sure what you were saying. Okay, so the third one is resistance, and I want you to put the little hyphens. This could be R for resistance. It could also be that symbol, okay? I think that's the omega symbol. It's Greek, but it's that upside down horseshoe looking thing. Okay, now resistance is the stoppage of electricity, or it slows it or stops it, okay, depending on how much resistance there is. So resistance is like you're hitting the brakes on your car. You can hit the brakes a lot and stop quick, or you can hit the brakes slow and it brings you to a slow stop. So resistance is kind of the same thing. We use resistance all over the place. It's very, very important concept for us as electricians, because almost every single problem that we encounter in electrical is going to be because of resistance. Too much resistance, somewhere in the line, okay? But resistance isn't always bad. Sometimes we use resistance for good things. So you guys all probably have some spot in your house with an adjustable light, like you turn the knob and the lights go up, or you turn the knob and the lights go down. Okay, so that's an adjustable resistance. We talk about those later in the class. We'll go through each one of those parts, but that's an adjustable resistor. And so when you turn the resistance up, the lights dim down because it's sucking a lot of the electricity out of it. When you turn the knob the other way and the lights turn bright, that means you're reducing the resistance, and you might completely reduce the resistance down to 0 so the electricity just flows and the light's fully bright, or you could start cranking the resistance up and dim the lights down. Okay, so that's resistance, and it's going to be a resisting of the flow of electrons. Another good example of those is in the robots. Sometimes, let's see, what would be a good one for the heat? Okay, so let's say like your air conditioning would be a good example. So you're flowing electricity through a line, and there's something called a thermistor, which is a thermally adjusted resistor. So as your house starts to heat up, the resistor starts to get more and more hard, or it could be more and more soft depending on how the resistor's set up. It doesn't matter, you could do it either way. But as the resistance starts to go up, as the heat in your room goes up, eventually there's so much resistance, and then the line will open on your air conditioner and turn it on. So we can use resistance for multiple things. Resistance is usually bad, but we harness resistance for good things too. Like I said, we have adjustable resistance in lights, and we also use resistance to read things for our computers too. When we do robots, we'll do that a lot actually. We'll read variable resistances. Okay, so those are the main three: volts, amps, ohms. Okay, volts, amps, ohms, or volts, amps, resistance, or volts, intensity, resistance. So there's a couple of interchangeable words, and then if you're in math or science, sometimes they change those around a little bit too. Like I said, for the math problems, it's going to be intensity is I for amps, but a lot of times we'll just use A or amps too. Okay, so let's go back. So those are the big three: volts, amps, ohms. And then the last thing I want to do today is current. Let's see here. Yeah, we'll just do a little quick brief of this. We'll go in depth on all these as we start using these circuits. But for now, let's just go AC, DC current, just like you're reading here. And there's two types of current: alternating and direct current. Alternating just means it's switching back and forth. Direct current means it's always flowing in the same direction. Let me see if I have a quick little circuit here. Okay, let me go to this one. Okay, we haven't learned circuits yet, but just follow with me for a second. So you see the positive on this battery, right? So you don't know what all this language is, but this is a battery here, and there's a plus side and a minus side, just like on your AA batteries, okay? So since we use conventional theory, the electricity is gonna flow out of this plus, it's gonna flow through the fuse, it's gonna get stuck because the switch is not connected. But if we drop this switch down, now all of a sudden electricity will flow. It'll come through this light, and then it'll go back through the metal and then back to the battery. So we have a complete circuit here, okay? Now, if we have alternating current, what's going to happen is the voltage is going to come out from the battery and then go back all the way to the other side of the battery, okay? That's direct current. It's just flowing out the plus and heading to the minus, okay? And it's going to do that the whole time if we're talking direct current. It only goes one way. But if we talk about alternating current, what happens is the two poles of the battery switch, and then all of a sudden the electricity is going to flow backwards to the battery. Okay, so it's going to go plus to minus this way, and then the battery poles are going to switch, and then it's going to go back the other way. Okay, that might sound confusing, but don't worry about it. We'll talk about it more later on. Okay, I wish we had the whiteboards and my displays in front of us because it makes it so much easier. But for now, just understand that alternating current is going to switch back and forth. I think Suleiman was talking about hertz earlier, or your frequency, and that switching occurs 60 times a second. So that's 60 hertz, okay? That's alternating current, and then direct current only goes one way. So for a definition, what you would put is direct current, electricity only flows one direction. For alternating current, electricity is going to switch back and forth between the two directions. Okay, and I'm going to kill it there for today because we only got about 2 minutes left. All right, any questions? Oh shoot, I didn't realize there's a few more chat things going on. Let me see here. Talk about watts. Yes, we will talk about watts. Those are very important. Watts are the same thing as horsepower, and that's a measurement of how much work is getting done. Okay, let me quit sharing this thing here. Okay. Yeah, so watts are just electrical work being done, and volts times amps equals watts. We'll do a little bit more of the math later on. Let's see here. Okay, I'm just checking to see if there's any more questions. Okay. Okay. Yeah, and somebody posted Ohm's law, and just remember you could use Ohm's law for all 3 directions. So he posted it one direction, but we can actually use it 3 different directions. Okay, good. Okay. I don't see anything else. Okay, so we're gonna kill it there for today, guys. Like I said, I wish we were in front of the whiteboard. It makes it a lot easier, and I had all my examples in front of us, but oh well, we'll deal with it. We only got a couple more weeks, and then we'll be back in the class. So we'll kill it there for today, and I will see you guys all back tomorrow, okay?
I have a question.
Yeah.
So on November 3rd or whenever we're going back to school, are we going back full time or are we doing hybrid?
We don't know. They're planning on doing the hybrid as of now, but if our county goes into, I believe it's the orange category, then we'll probably be back full time. So we don't really know because it's not in our control. So unfortunately, they're scrambling around crazy in the office trying to get it ready for hybrid. And then there's a decent chance that we won't even be in hybrid. So I don't know yet. Nobody knows yet.
And do you know how the schedule is going to work? Because my dad said that they're going to send the schedule out for everyone. Like,
For the hybrid?
yeah.
Yeah, the hybrid's a little more confusing. I don't know it exactly. All I know is there's a morning shift and an afternoon shift. And I do also know that they're finalizing that. And I think they said they were going to have it out like, was it the 15th, October 15th or so? So they don't have the schedule yet. They're still working on it. It's extraordinarily complicated.
But will we be eating lunch at school or are we going to go back home at secondary like our switch time?
I'm not sure I heard that one exactly. Were you asking, are they doing the hybrid?
No, like, are we still going to have lunch at school or is that going to be
Oh, I
when
don't think
we
they're having
switch?
lunch at school, no. I think you're supposed to go home for lunch. That's in one of their restrictions is that you're not allowed to meet like that for lunch. So they're having like a whole special thing like where you have to leave in between.
Oh,
So yeah, there will not be lunch. That I do know.
okay.
All right, I got to get to the second period. I will see you guys tomorrow. Have a good one.